In this section, we'll multiply radical expressions together. So in example 1a, we have 3 times the square root of 5 times 4 times the square root of 2. It's important to realize that we have times signs that are not written there but are implied. So when you multiply numbers together, you can multiply them in any order. So I'm just going to switch the order. I'm going to multiply those whole numbers first and then the radical second. And you can group them any way you want. So I'm going to do 3 times 4 first and get 12. And then the square root of 5 times the square root of 2. Since both those factors are under a radical, when we multiply them together, we get the square root of 10. The result is under a radical. 10 doesn't have any perfect square factors, so that's fully simplified. All right, let's check out B. 5 square root of 3 times 2 times the square root of 3. So I'm just going to rearrange the order. Multiply. And then simplify that square root of 9. Square root of 9 is 3, and 10 times 3 is 30. That result turned out to be a whole number. All right, you try A below on your own and pause the video while you do this. For this, you should have gotten 21 times the square root of 30. All right, now try B and pause the video. This one had a whole number result, 30. All right, now let's move on to a different kind of example. We're going to be squaring. Now we remember from our work with exponents that squaring just means multiplying by itself. So square root of 5 times square root of 5 is the square root of 25, which is 5. Now what you'll notice here is that when you square a square root, they undo one another, and you just get that number in the radicand, or the 5, right? The square root and the square undo each other. So when you have the square root of 71 squared, you're not actually going to do 71 times 71. We don't really care what that number is. It's just important to know that that result is going to be 71 when you square and then take the square root, because they are inverse operations. All right, let's check out another. This is the square root of 6 squared, which is the square root of 36. We're just going to do the inside operation first, and that's 6. Now this is in a different order. We squared first and then took the square root, but the result is still the same. They undo one another, so we're just left with that number 6. So similarly, when we take the square root of 103 squared, that's just going to be 103. All right, check out the ones below and try on your own. Try A. Pause the video. That should have given you a result of 65. All right, let's try B now. The square root of 219 squared. And yep, that should have given you 219. No need to actually square 219. Just know that the square root undoes the squaring. All right, let's check out something a little bit more complex. 6 times the square root of 2 squared is 6 times the square root of 2 times 6 times the square root of 2. So just treat this as a multiplication. That's 6 times 6 times square root of 2 times square root of 2 is 36 times, and that'd be the square root of 4, which is 2. And then that's going to give us a whole number, 72. All right, let's check out B. 10 times the square root of 17 squared is 10 times the square root of 17 times 10 times the square root of 17. And that's 10 times 10 times the square root of 17 times the square root of 17. Now remember, when you multiply a radical times itself, that's like squaring. And when you square a square root, they undo one another. So we've got 10 times 10, which is 100, times the square root of 17 times the square root of 17, which is 17. So that's going to give us 1700 for our result. All right, your turn to try one. Try A below and pause the video while you do this. Okay, you should have gotten a result of 45. So I just, without rewriting the multiplication, I just did the 3 times the 3 first to get 9, and the square root of 5 times the square root of 5 to get the square root of 25, or 5. All right, now try B on your own. Pause the video. All right, this one had a result of 92. All right, now let's try. Well, let's not try anymore. That's the end of the video.